Welcome back. This is the second video on structs. A structure, the struct statement allows you to define a multi-valued heterogeneous data type from which you can create variables that have a single name but consist of many values. A struct is in many ways similar to an array. The example here, we have an array of 42 integers. And the name age, which is the array name, refers to many values, 42 values. And it also contains 42 variables. And the variables are formed by the variable name followed by a subscript which identifies a single integer. So the subscripts for the 42 values are sub 0, sub 1 through sub 41. And all 42 of the variables have the same data type. Hence, an array is multi-valued homogeneous. We said that a struct allows you to create a data type that is multi-valued but heterogeneous. So let's take a look at the syntax for a struct. Not the syntax yet. Yeah, here's the syntax. Here's the statement. Struct st is the data type, and this data type consists of 1, 2, 3, 4 different types of values: an integer and a float and a string and a character. Notice that there's 4 values associated with the data type, and each one has a different data type. So when I create the variable myStuff, it's one variable that refers to 4 values, an x, y, z, and c value. The variable myStuff means all 4 of these values. Now, just like with an array, the variable, said this wrong. It's not age, it's myStuff. myStuff contains 4 member variables. These member variables also have other names, like they're often called fields or attributes. So myStuff consists of 4 variables. They are called myStuff.x, myStuff.y, myStuff.z, myStuff.c. Notice the dot is important because we are saying that myStuff.c means there's a variable called c, but that variable belongs to a variable myStuff. Technically, there is no variable floating around called x, y, z, and c. Each one must be attached to a variable. Notice the 4 variables do have different data types. Now let's continue. So we're going to talk about the use of functions with these variables. So let's take a look at this function here. Let's take a quick look at it. Go to the top. Here's our data type student, and let's look at the main. In the main, we are creating 3 student records, S1, S2, and S3. The variables of type student, we call those records. We're going to call a function called readStudent, and we're going to pass to it one of the variables. We're going to pass one of the variables S1, and we're going to use a file. Up here we open a file called studentf. That's an input file. We're going to read from the input file. We're going to read values into S1, values into S2, values into S3. We're not going to do this yet, but we're going to later on we're going to write a function that will display one student. We will call that function 3 times as we have it here. But let's take a look at this function readStudent. So if we go up here, we see that readStudent is a function that takes two arguments, a stream. As a rule, whenever you pass a stream, it must be passed by reference. So the ampersand must be there. And the reason is, when you read, you actually change where you are in the input buffer so that you don't read the same thing over and over. So you must be able to change the stream. Similarly, I'm passing a record in, a record called S. I'm passing it in by reference, which means I'm granting this function the ability to change the fields within this record. So when I do an input, I want to see the values of the fields change. All right? So normally, if you're passing a variable, in order for input to be performed, you must pass it by reference. All right. So we're going to run this. We're going to compile this and run this and see what we have. Oops. When we do that, what we see on the end is just a calculation of the average. All right. Now let's do something. I got to prove a point to you. What if we go here and remove the reference, remove the ampersand, and we're calling this time not by reference, we're calling by value. Let's see what happens if we do that. When we do this, what's going to happen? Notice that we're getting garbage out. Notice that we went from a real number to garbage. It's because we really haven't read any data. So again, leaving off the ampersand changes, it prevents you from actually reading data into the records. And I hope that point is made clear. Now, what we're going to do now, and I need your help, is I want to address displaying the three students. How do we display the three students? Well, displaying is kind of like reading, so you would expect that we're going to call the function up here called showStudent. This is the function we're going to call. Notice that I'm also passing this by reference. Is that necessary? Well, it's certainly necessary if you intend to change the fields of this record. Look at the output though. Am I changing the fields of the record from the output? No, I'm not. So technically I can take this out. Let's just do it. We'll do it when we switch. So let's switch to a new version of this and go back in, and here's the version where we put the function in now. Notice that showStudent, we're actually doing some formatting here. I'm going to go ahead and do some formatting so it comes out looking neat. And when we let's change the function here. Excuse me. Let's do the calls. So to call it, when I show, I want the outputs to come to the screen. So I'm passing as a first argument an output stream. Let's look at the function. The function requires what? An output stream. Cout is an output stream, so I can make that the first argument. If I had an output file, I could output file stream. I could also pass the name of that stream, because an output file stream and an output stream all fall under the category of OStream. So let's run that. And we see the outputs come out. Okay. Let's go in and tamper with this for a moment. Let's go in. Let's go in and take this out. See what happens. See what happens. When we run it, we get the same output as we had before. So that ampersand is not important. How many of you all are saying, let's take this out and see what happens? Let's see what happens. Okay, get a chance to learn something. Compile. and run again and see, it's basically saying I can't do this. So it doesn't make sense to run. So it won't let you do that. It forces you to pass this by reference. Alright, so that's good. Alright, so we're good. So let's summarize. We have seen that we can pass a variable of a structured type just like any other type. This is no different than saying int. As long as you understand that this is a multi-valued heterogeneous, so you need to know the names of the fields so that you can reference the fields. With that, we're going to stop. In the next video, we're going to talk about how do you initialize things. So we're going to stop.